Good morning to all. Today we discuss about the topic. It is adversarial search. So the adversarial search having the two methods are available here. First one is the min-max algorithm. Another one is the alpha beta pruning. So first one is the min-max algorithm. So what is meant by min-max algorithm? So basic definitions are there. We are dealing with the two players. One player will assign as minimum, another player will assign as maximum. It is mainly used in game playing applications like chess games and tic-tac games are also used in the min-max algorithm. So the first concept min means minimum value. So you should always consider the minimum value. The second one is the maximum. So maximum means maximum that always considered as a maximum value. So these are the two conditions available in min-max algorithm. By default values, maximum means you should update the value of minus infinitive, and minimum means it will update the value of plus infinitive. So this is the main things. Okay, so first min-max algorithm, we are dealing with two players. So one player will assign as minimum and another player will assign as maximum. So this is the basic logic. So this is one of the given tree for the example of min-max algorithm. So there are set of values are available from the root node and leaf nodes and middle of the nodes. So first the root node having the values to how to calculate the values to, so we will see in the example. So applying min-max algorithm, the general calculation should be followed. So first one, maximum. So maximum means you have to calculate the value from bottom to top approach. That means again we have to backtracking the all the nodes with the help of min-max algorithm. So maximum you should consider the value from the left child or left children. So maximum the left children having the root node having three nodes are there. So three nodes having the some set of values are there. So first one is minus 2 comma 2 comma 1, and also you should include the value of minus infinitive. So in this four values you should calculate the maximum value for the given tree. So which one is the maximum value? Minus 2 comma 2 comma 1 minus infinity. So obviously 2 is the maximum value. So therefore the value of the root node is 2. So here in this section you should update the value of maximum in the root node. That is the main logic in maximum of minus infinitive. Second, in the right child having the three children, so 1 comma 3 comma 4. So you should update the value of maximum value from the three leaf nodes. So 1 comma 3 comma 4 comma minus infinity. So which one is the maximum value for from these four values? Obviously 4 is the maximum value. So therefore the root node having the values of 4. So 4 should be placed in the root node. So in the next same thing will happen in the right child or right children. So right children having the two subtrees. So one is called minus 1 comma 1 comma 0, and then right side having the children's 2 comma 5 comma 6. So when we calculate the minimum value, you should include the value of alpha. So you should evaluate these three values. So from the left side, minus 1 comma 1 comma 0. So okay, so minus 1 comma 1 comma 0, obviously. So this is the right child of maximum value, and the same thing, the minimum you should calculate the maximum value from this node. So which one is the maximum? 1 is maximum. So therefore the root node having the value of 1. In the right side having the three children, 2 comma 5 comma 6 comma minus infinity, 2 comma 5 comma 6 comma minus infinity. So from these four values, which one is the highest values? So my 6 is the maximum value. So therefore the root node having the value of 6. So this is the answer for the root node for the given tree. Then again you have to calculate the in the middle of the node. So middle of the node having the two children from left side and right side. So you should calculate the value of in this root node. You should update the minimum value. So this root node having the two values 2 comma 4 comma and infinitives. Here the value are calculated here 2 comma 4 comma minus infinitive. So which one is the lowest value? It is the 2 is the lowest value. So therefore you should place the value 2 in the root node, and then similarly you have to calculate the value of right child. So right child having the 2 nodes, so 1 comma 6 comma infinitive. So which one is the lowest value from these 3 values? 1 is the lowest value. You should place the value 1 for the root node here. Okay, so this is the minimum value we have to taken the for the given leaf node. And then the root node, how to calculate the root node for the given tree? So root node having the, you should find the value of maximum value from the subtree. So 2 comma 1 comma minus infinitive. So which one is the highest value from these 3 values? 2 is the maximum value. So therefore you should place the value of 2 in the root node. So this is the decision tree, how we calculate the min-max algorithm with the help of basic formulas. Okay, so another one drawbacks about the min-max algorithm. Main drawback is the time complexity. So time complexity is one of the major drawbacks, because if you find out the root node value for each and every nodes, you have to backtracking again and again, both left children, right children, it will take more time. So that is one of the main drawback in min-max algorithm. So in this algorithm, to play game is applicable for the min-max algorithm. One is called maximum, another one is called minimum, that is called max and min. So both the player fight it as the opponent player and gets the minimum benefit while they get maximum benefit. So both the player of the game or opponent of each other, so where the maximum will select the maximized value for the given problem. So the Minimax algorithm performs a depth first search algorithm for the exploration of the complete game tree. So it is mainly used in the game applications, they are used in Min-Max algorithm. So in Min-Max algorithm proceeds all the way down to the terminal node of the tree, then backtrack the tree as a regression. So what is mean regression? Regression is nothing but until the condition is satisfied. So we have to process the root node again and again until the condition is satisfied, that is called regression. So from this graph we have to calculate the value from the leaf node. This is called leaf nodes. The bottom nodes are called leaf nodes or terminal nodes. So you have to find the value from bottom to top approach, that is called regression, again backtracking. Then maximizer will try to get the maximum possible score and minimizer will try to get the minimum possible score or the given set of conditions. Then another one is that's all about the min-max algorithm and basic definition and how to solve the problem with the help of that algorithm. The next concept is alpha beta pruning. So alpha beta pruning is a modified version of min-max algorithm. So this is a modified version of min-max algorithm. So it is an optimization technique for the min-max algorithm. So this is one of the mathematical concept. We are applying the formula, basic formula, and we find out the solution. So alpha beta pruning is the pruning, cutting down of useless branches in decision tree. So this is the basic definition about alpha beta pruning. So alpha, it is the highest value, that means initial value of alpha is equal to minus infinitive, and the maximum player will only update the value of alpha. So in this stage the maximum player only will update the value of alpha. So beta is the lowest value. The initial value of beta is plus infinity, that means positive. So minimum player will only update the value of beta. So the minimum player will only update the value of beta. So in general condition, alpha is greater than or equal to beta. So if the condition is satisfied for the given problem, you no need to traverse the remaining nodes or remaining subtrees for the given graph. So this is the basic condition about alpha beta pruning. So this is one example of alpha beta pruning. So A, B, C, D, E, F, G, H, I, J, K, L, M, N and O. There are set of nodes are there in the alpha beta pruning, So this is one of the tree. Here this is the first stage, so maximum will update the value of alpha. The second stage you should update the value of minimum beta, and the third stage maximum value of alpha should be updated. And the last one is the terminal node or leaf node. So the terminal node having the some set of values and their weights are there. So first is 1, H contains 1, and I contains 2, and J contains 5, and K contains 7, and L contains 0, and M contains 1, N contains 6, and O contains 4. There are set of values, weightages are available in the leaf nodes. So in the initial stage, alpha is equal to minus infinitive for the root node A, and beta is equal to plus infinitive. Then root node B, alpha equal to minus infinitive and beta is equal to plus infinitive. And then the root node D, alpha is equal to minus infinitive and beta is equal to plus infinitive. This is the initial condition. And then from the step 1 diagram, you should calculate the value of maximum alpha. So from the root node D having the two children H and I, so compare those two children, which one is the highest value from the leaf node. So obviously 2 is the highest value. So therefore now the alpha value should be updated as alpha is equal to 2 and beta is equal to infinitive. Similarly you have to calculate in the right side. So the E node having the children J and K, so that children having the children 5, 7. So which one is the highest value from these two nodes? So obviously 7 is the highest value. So therefore alpha is equal to 7 and beta is equal to infinitive. So the same thing will happen in the right side. So F contains two nodes L and M. So you have to calculate the value of F. 0, 1. Which one is the highest value from these two values? Obviously 1 is the highest value. So therefore the root node having 1. And G has two nodes N and O. They are having them set of weights 6, 4. So which one is the highest value for these two values? Obviously 6 is the highest value. So therefore the root node having the 6 is the final answer for the given root node. So alpha is equal to 6 and beta is equal to infinitive. Okay. So this is the step 1 first diagram. And then step 2 second diagram, you have to again calculate the value of minimum value. You should update the value of minimum value beta, okay, on the second stage. And the third stage, see the diagram about the third stage. From this A, B, C, D, E, F, G, H, I, J, K, L, M and N and O. So from this root node, the root node E having the two children J and K. So in this stage alpha is equal to 5 and beta is equal to 2. So after calculations of E, root node E, we will get the answer alpha is equal to 5 and beta is equal to 2. From this stage you should check the basic condition. Alpha is greater than or equal to beta. So 5 is greater than or equal to 2 means here the condition is satisfied in this stage. So therefore you have to no need to found the answer for K of the right side, okay. So because the condition is satisfied means you no need to traverse in the right side, okay. Once the process is completed, you have to check the another say right side or right children, okay. This is step 3 diagram. And then step 4 diagram, this is the step 4 diagram. So in the step 4 diagram is on one of the example. So here the C node, root node C having the alpha is equal to 2 and beta is equal to infinity, okay. Alpha is equal to 2, beta is equal to infinity means the basic, you have to check the basic condition. So alpha is 2 and beta is equal to 1 because the F root node having the weight of 1, okay. So now the condition is satisfied in the right child of right children. So therefore no need to traverse for the G, N and O. So this is the final answer for the alpha beta pruning. So this is the basic example about the alpha beta pruning. So all the nodes are visited. So now in the above tree diagram all the nodes are visited and we get obtained result. We will get the obtained results. So the remaining nodes are removed while the condition is satisfied. So because the basic condition is satisfied, alpha is greater than or equal to beta, the condition is satisfied means you no need to traverse the remaining nodes. That is the main logic about the alpha beta pruning. Okay, so the next one is constraint satisfaction problem. Constraint satisfaction problem, you take the example for map coloring problem. Map coloring problem is one of the example for constraint satisfaction problem. So I choose the map as Australian countries. So Australian countries having the set of continents are available there. So first one is the Western Australia and Northern Territory and Southern Australia, Queensland and Victoria and Tasmania. These are the some continents available in Australian maps. So in the Australian map, the same thing will happen into right side. You should separate the continents with this map coloring problem. So Western Australia and Northern Territory and South Australia and Victoria, Queensland and Tasmania. Okay, so these are the main major continents available in the constraint satisfaction problem. So the basic concept in the constraint satisfaction problems are two adjacent regions cannot have the same color no matter whatever color we choose it. Okay, so this is the basic condition. Two adjacent regions cannot have the same colors. Okay, that is the main logic, no matter what color we choose it. Okay, and then the second concept is the goal is to assign the color to each region so that the no neighboring regions have the same colors. No neighboring regions means nearby the region should not have the same color, should not be applied. That is the main logic. So coloring the following map, we have to choose red, green, blue such that adjacent regions have the different colors. Adjacent regions are having the different colors. And then this is the next step for color mapping problem. There are certain constraints are available in color mapping problem. So first one is the variable. So variable means in which country you chosen, and those countries contain some list of continents are available there. So the list of continents, the initial letters should be considered as a variable. So Western Australia, Northern Territory, Queensland, like NSW, V, SAT are the variables of the given color mapping problem. And domain means whatever the color we choose it is called a domain. So red, green and blue. So I choose the three colors red, green and blue. So these are the domains. Then constraints means adjacent regions must have the different colors. For example, WA is not equal to NT. So that means constraint means a basic condition. So adjacent region is must have the different colors. So this is the step-by-step diagram for color mapping the problem. Initially the continent should be empty, and then second stage the continent should having the two colors red, and the third stage having the three colors, so green, red and the third fourth stage having the three colors, so red, green and red, and fourth stage red, green, blue, and then the fifth stage having the colors of green, blue, red and red. So they are the different continents with the different colors are applied in the Australian map. So the same thing will happen in the subcontinents of the given countries. Okay, so red, green, blue, and then these continents having red, blue, and this continent having green, and this continent having blue. So these are the different continents with the different colors red, green and blue. Okay, red, green, blue. Okay, so now the solution is WA is equal, after you applied the colors for different continents, you should mention the final solution. So Western Australia having the red colors, and Northern Territory has a green color, and Queensland having a red colors, and NSW is equal to green color, and B is equal to red color, and SA is equal to blue, and T is equal to red. This is the final solution. And finally you have to draw the constraint graph. This is the final stage. So Western Australia, Northern Territory and Queensland, SA and B and T, the Tasmania. So the Western Australia having red colors, and Northern Territory has a green color, Queensland having the red colors, and SA having a blue color, and B is a green color, and T is a green color. This is the final graph about the constraint map problem. Okay, so that's all about the constraint certification problem. And another one is the basic definition about the alpha beta pruning. Alpha beta pruning is a modified version of the min-max algorithm. It is an optimized technique for the min-max algorithm. Alpha beta pruning is the pruning, cutting down of the useless branches in decision tree. Alpha beta is, there are two concepts are implemented. One is alpha, another one is beta. Alpha means highest value, alpha is equal to minus infinity, and beta means lowest value, so initial value of beta is equal to plus infinity. So maximum player will only update the value of beta. This is a general example about the alpha beta pruning. So that's all about today's topic. So any doubts or any clarifications? Thank you for all. Thank you one and all.